Welcome to the program. We're on number 3 now, which they give you the equations. Y equals x plus 6, and this is y equals 2x. Those are the two givens. So if they're both solved for in terms of y, the easiest way to do it is substitution. So we're going to substitute in, since they're both y, I could say x plus 6 is equal to 2x because they're both equal to y. So now I could subtract x from both sides, and I have x equals 6. Okay? To get the value of y, I can go back into either equation 1 or equation 2. Y equals 2 times x, so y must equal 2 times 6, y must equal 12. So the coordinates of the solution are 6, 12. And we use substitution, so that's A. Okay? Moving on to number 4. We have 3x plus 2y equals 7. And we have y equals negative 3x plus 11. So it's a substitution again because we have this one in terms of y. So I'm going to go into the first equation with the left-hand side of the second equation. So the first equation again is 3x plus 2, but instead of y, I'm going to say 2 times negative 3x plus 11 equals 7. So that's equation 1 with only x now. 3x minus 6x plus 22 equals 7. Now we say negative 3x equals negative 15. So x must equal 5. If x equals 5, then I can easily get y now. I'll go back into equation 2, which is here. I'll say y equals negative 3 times 5 plus 11. So this is negative 15 plus 11, which is negative 4. So the answer here for the solution set is 5, negative 4 solves both systems, both equations in the system. For number 5, we have 3x minus 4y equals negative 24. The second equation is x plus y equals negative 1. So you can do many things here. You could do elimination, you could do substitution. Let's try elimination. So I'm going to multiply the second equation by negative 3. So now the second equation transformed is negative 3x minus 3y equals positive 3. Now I can add them. So if I add this equation with this equation, you see the x's cancel. That's why we multiply the second equation by negative 3. 3x plus negative 3x is 0x. Negative 4y minus plus a negative 3y is negative 7y. And then negative 24 plus 3 is negative 21. So divide both sides by negative 7. Y equals 3. If y equals 3, then we could say x plus 3 equals negative 1. We could say x equals what? Negative 4. So the solution set here is negative 4. 3 is where the two lines intersect. Okay? And that was choice A. For number 6, similar again, we have given 5x plus 7y equals 32, and then 8x plus 6y equals 46. Now we have to multiply both equations by constants to eliminate. We need to use elimination here. So I'm going to multiply the first equation by positive 8, and then the second equation by negative 5. So the first equation becomes, I'm going to do it on the right-hand side here, 40x plus 56y equals 256. Second equation becomes negative 40x minus 30y equals negative 230. If I sum these, the x's cancel, and I'm left with 26y equals 26. So y must be equal to 1. And if y is equal to 1, now I can substitute back in. I'm going to go back into the first equation. So that's 5 times x plus the original equation, 7 times 1 equals 32. Where did the 1 come from? We just got it over here. So that's equation 1 with y substituted in as 1. Now we have 5x plus 7 equals 32. 5x equals 32 minus 7 is 25. So x must be equal to positive